So let's look at one that we're going to do without a calculator. Find the area bounded by g of x equals negative x, h of x equals negative x squared minus 2, x equals negative 1, and x equals 1. So we have to sketch these by hand. So we'll start off with our axes. And let's start off with g of x equals negative x. We know that normally x looks like this. A negative x flips that over, so we're going to have a function going down like this. And then negative x squared would look like this. It's negative, so it's been flipped over. Minus 2 moves it down 2. So we're going to have something that looks a little bit like that. We see that our bounds are x equals negative 1 to x equals 1. We can see g of x is on top, so we're going to have the integral from negative 1 to 1. G of x is negative x. And then we're going to subtract negative x squared minus 2, because that one's on the bottom. And the width of one of our representative rectangles, that's dx. So, if we don't have the calculator with us, so I'm going to mark this no calculator. Then after we've sketched it, we just have to work this out by hand. So we're doing integral from negative 1 to 1, negative x plus x squared plus 2. Negative x squared over 2, I'm taking the antiderivative, plus x to the third over 3 plus 2x. All this from negative 1 to 1. So negative 1 squared over 2 plus 1 cubed over 3 plus 2 times 1. And then we're going to subtract negative 1 squared. Remember, that's in parentheses. Plus negative 1 cubed over 3 plus 2 times negative 1. Okay, that gives us negative 1/2 plus 1/3 plus 2 minus, so negative times negative is a positive times negative is 1/2 plus negative 1/3 minus 2, and then we distribute this negative. These two subtract to be 0. So we have 2/3 plus 2, which is, plus 4 times 3 over 3, so that's 2/3 plus 12/3, or 14/3. You can also find the bounds by hand if you need to. Let's say this is also no calculator. Got the area bounded by f of x equals 2 minus x squared and g of x equals x. So when we're drawing this, we know that g of x equals x is just a line like that. This is negative x squared plus 2, same thing. So negative x squared is upside down, plus 2. It's going to be coming up something like this. Now, as soon as we figure out what these numbers are, so whatever x equals over here and whatever x equals over here, we can put them into our bounds. Here's our representative rectangle. We don't know what those bounds are yet, but we do know that we're going to have a dx. We do know that f of x is on top, so that's 2 minus x squared minus g of x, which is just plain old x. And what we do to find the bounds, the intersection points are the points where the f of x and g of x are equal for the same x. So all we have to do is set them equal to each other. So g of x is x, f of x is 2 minus x squared. If we have an x squared and an x in here, what we want to do is we want to get everything on one side and set it equal to 0. So I'm going to add x squared, subtract 2 to both sides. Because once it's equal to 0, I can factor it, and then use that in order to figure out what these two x values have to be. So this is clearly the negative one, and this is the positive one. So that gives me my bounds here from -2 to 1. This is almost identical to the one that we just did, so rather than taking the time to do this one all out by hand, I'm just going to check and see what the answer is. So math 9, 2 minus x squared minus x, comma, -2, comma, 1. That's going to be 4.5. I leave it as an exercise to you to work that one out.